This is the last demo of this session, and I know you're all tired, but I think we will try to make it as fun as possible for you guys too. First of all, the presentation is called Acquiring Distribution System Services through the FLECH. All right? So we're already setting the scenario there. This is going to be about FLECH and how we trade with FLECH. I'm here representing DTU, as well as Anna Stavlo over there. Lift your hand, please. There. Then we have Ole Sundström from IBM there, and Carsten Sø from Zero Software there. They will be helping me during the presentation, pushing the right buttons, you know, all the implementation stuff. That's those guys. All right, so let's start off by talking, where are we now? I would like you all to imagine yourself jumping 3 months into the past. That's why we have that date over there. All right, we're 19th of August, 2014. I am a DSO right now, and I'm planning ahead the reinforcement for the grid and so on, and I see that at a certain moment, there will be a congestion issue in one of my feeders, or one of my transformers, or whichever element. So I can always choose between two things, reinforce or acquire flexibility. Now, how can I acquire flexibility? That would be through the FLECH that provides the acquisition of flexibility services, is this interface between Aggregator and DSO. Who do we have available on our grid right now as aggregators? We only know of two. We know of DTU CE aggregator, again, Anna's there, and we know of Zero Software aggregator, Carsten over there. So, the congestion problem we see is that, let's suppose it's a transformer, that we want to keep the load below 175 kilowatt. All right, because we want to have the rest of the transformer as a reserve in case of a fault in a neighboring transformer, so we can split out the power there. So, as it is now, our prediction says that we will go 8 kilowatt above this 175 limit we have. Now, as a real DSO, that we have a few around here, I know that 8 kilowatt probably is nothing. But just for the sake of argument, please follow me. So, let's recap a bit about FLECH. In this presentation, we are focusing on 4 of the main aspects we believe why FLECH is important. First of all, it's a standardized method for acquiring flexibility. Second of all, it provides a transparent way of transferring this flexibility. That means that we can see quite clearly who is bidding and so on, so there's no favoritism. Again, bear with me this time, because today our DSO and our aggregator for DTU is actually Anna, so he's working for both companies and has insider knowledge of both things, but this is just for the demo. It facilitates visibility of the service need towards those who can actually provide this service. So that means that the DSO posts on FLECH, hey, I need this amount of reduction, can anybody please supply me? And then all the available aggregators on that area will say, yes, I can, or no, I can't, or I can provide this much. And finally, it provides a clear legal framework. So what happens if one of the aggregators go bankrupt, and what happens if one of the aggregators doesn't perform as expected, and all this settlement part. You can see the interaction will be like this. We have the DSO talking to the FLECH operator. FLECH operator today is Ole. The DSO is Anders. Then we have 2 aggregators, Carsten and Anders again. And one of these aggregators will be controlling a unit down here at the distribution level. Today's unit will be the Flex house that some of you just saw. Some other of you have seen pictures of it earlier in the event. I think yesterday Oliver presented some pictures of it. So this is the setup we'll see. Now, we will show each of these 4 phases that you usually see in the power system. We will start off with the planning phase. showing the acquisition of the flexibility service. We will go on quickly through the scheduling phase. This is not really relevant for us, and I'll explain why. Then the operation phase. There you will see some real stuff going on. You will see some numbers changing over here. You will see, well, you won't see, but the flex house will start actuating. That will be reflected here. And then finally the settlement phase. Throughout all of this, we will have these two screens helping me along. So if you feel lost at any moment, this part here will tell you where we are in the process. If you feel completely lost, then in the folders you got yesterday, there's also this same diagram so that you can follow what's going on there. And this window is actually a FLECH window. So this one will be showing when there's open a market, when it's receiving messages of bits, when it's clearing, and so on and so forth. All this first part is usually automated, but today we actually press a button. So we've implemented a button to go through the phases. And when I say we, I mean Ole. So it's almost a final product, except for these small changes we've done for the demo sake. So this is also running on a cloud service somewhere. And then that is communicating between the two aggregators here, and the two aggregators are then communicating out to SysLab. So we have some complex interaction here with regards to communication, which goes out in the world and then back in. That is assuming that the cloud platform is not running somewhere here in Copenhagen or something, but I don't think so. All right. So we start out by the tender announcement. So there's a bit of data here. First of all, it's the market period. So in which period is the market open for the aggregators to bid in? So this is today. Remember that we are in August today. So only for today this market will be open. When is the reservation period? When does it need to perform? That will be 3 months from now, the 19th of November, 2014. So yeah, we have invented some time travel technology, so don't worry. You won't start to get gray hair or lose it like me. The activation period is denoted here. This is the period where the aggregator will perform, and then the volume that it needs to down-regulate or up-regulate if you're actually talking as a service. I will go into these details later on, but in order to get the whole thing rolling, I will pass the word to Anders so that he can show you how he makes the tender announcement from the DSO perspective.
Yes, so now you have to envision yourself like a really, really nice DSO interface to FLECH. So this is what we came up with. It's probably not as nice as it could be, but for demonstration's sake, it will work. So here you see the numbers that Esteban just introduced. So we have the market period, which is today in August. We have a reservation period, which is today, which is convenient for this presentation. We have the activation period, which starts in 15 minutes. And then we have a maximum price that the DSO is willing to pay. We use this to clear the market. So if we have aggregator bids that is above this value, we can kind of clear them out because they're not relevant for the DSO. Yeah, I should mention that this cost that the DSO is willing to pay is not forwarded to the aggregator. So this is some knowledge that stays with FLECH. And then finally, we have the power reduction that we request. And here we have the areas or point of deliveries. The SysLab and the Dso, the two aggregators that we want to control.
Well, let's point out that's actually the two areas that we want to control, not necessarily aggregators.
No, that's entities in the grid, distribution grid.
Yeah.
So what we will do now is that we will submit this tender, which will go into FLECH. So now FLECH registered this market. And actually you can see that there's a bid already. That's because Dso bids into the market automatically. So Dso received the message and replied to it. So maybe I should, yeah, maybe, do you want Ole to introduce? Okay, so what we will do now is go to the SysLab aggregator interface, which is nice and smooth, like the other one. So now we're sitting on the other side of the table, playing aggregator. So here we have registered that this market has been opened. FLECH has sent a notification to us. And we can see some parameters for the market. So we have the market period. We have an activation period and a daily activation period. So the way it's conceived, I think Esteban will go into this later, that you have an activation period, which goes over some months, say, and then you have a daily activation period. So every day within the activation period, you have activation. But today it will only be once. And the SysLab and Dso bidding areas. And yeah, luckily we're in the SysLab bidding area. And here we can specify the volume that we are able to regulate down, and the power max, that's the maximum value of kilowatts that we will consume. And finally, we have a price. So I will submit this tender now, which should be registered by FLECH. So now we can see the second offer here in the FLECH interface. So yeah, we actually, so I'll just go here. So now we will go to the clearing phase. So we have 3 computers over here trying to keep track of. So what we can do now in FLECH is that we can actually clear the market.
And just this would have happened automatically at the closing of the market period if we had the real thing running. But again, for the sake of the demonstration, we decided to put these buttons in case we were a bit behind schedule or ahead schedule. Another detail here you can see, I mean, you can already guess who's going to win this bid, right? I mean, we can see the prices there. If SysLab won, then we would be using the dump load that's right behind this screen, which is just a set of big hair dryers, like this size. And this would, if Anas had won today, we would all be very, very warm in about 10 minutes. So that's why I asked him, please, please don't win the bid.
And maybe as you can note here, the orders have been arranged in merit order, which you use also in the Nordic power market on Nord Pool. So you kind of, you activate the cheapest bid first.
And that is the definition of this market, specific market. There are other services that could be handled differently, maybe a first order, first served. We've chosen to follow this, which is common also in the primary frequency, no, in the manual regulating power market. This is the internal of the aggregator. Do you mean over here? You have to click in on the offer in order to see these 2 kilowatt.
You can actually go into detail. Not now. Okay.
Oh, no, okay.
Okay.
But you will see it. It turns out in the settlement. It's used for the settlement. Have you cleared?
No. So we will clear the market. So yeah, I think Ole should explain now what is going on with these plots that we presented.
Sure. Maybe we can zoom in on one. So what you see now is that there's some rules to this market, which is that you have to provide full delivery after 1 minute. And you see the green area, which is where the aggregator has to be during delivery. You also see that FLECH gathered meter data, historical meter data for a period similar like this. And this is the gray line. And this is used to calculate this predicted baseline for this offer. So this is what we see. And later on, after the settlement, we will also see the real measurement for the winning bid.
Yeah. One of the reasons we see this prediction here is we're discussing a lot how do we know when the aggregator bits in saying, I can go from 10 to 2, that's difference of 8? How do we know that's actually what they would have used? Some people call it the baseline problem. It's maybe not exactly that, but we, through discussion with Silas and David from Dansk Energi and with Lars Henrik from Dong Energy and so on, we agreed upon this solution where the FLECH receives historical data and contains some forecasting methods where it says, well, if you had performed as you would usually have done, yes, indeed, you would have gone from 10 to 2, or you would have been up at 10. And so the 10 to 2 is this 8 kilowatt reduction that you promised. So I validate your bid, and therefore it's accepted in the market. So that is the reason for this timeline to be there. Can you give me back the...
I think we should go back to the aggregator window.
Yes.
Window. As you can see here, our offer was rejected, which we planned to be, luckily. So that means the Dso won. So I think it's time to introduce the Dso user interface. And I think Karsten will talk a bit about what is being presented here.
Well, as you can see on the screen, we received a PowerMax open notification at the bottom. Right after that, the client provided an offer of volume of 8 and a max power of 2 in the area called Dso, and with a price of 400. And as soon as they pushed on the clear button, we received a PowerMax offer. No, sorry. After we sent the offer, we get an offer acknowledgement from FLECH, telling the system that our offer has been received. Yes. And as soon as the FLECH clears the market, we receive, because we won the bid, we received a contract, and the system responded to that contract, telling FLECH that we have received the contract and accepted it.
Yes. All right. So we will go on to the scheduling phase now. So this means that we're going to run in time. We're going to jump. And there you go. Time is running so fast that you won't imagine. The reason why we don't touch much upon the scheduling phase is because this is an internal thing of the aggregator. Some aggregators, like predictive aggregators, will probably do some scheduling around there. But some other aggregators, like we've seen PowerMatcher, for example, or the aggregator that Giuseppe presented yesterday, they only take real-time data and the moment, and they don't use predictions in order to plan. So they wouldn't need this scheduling phase. They would just perform at the moment the service starts, right? In this case, we have a kind of service or aggregator that doesn't require a scheduling phase either. It will just send out the signal to the flex house, and it will perform. So that is what's going on now, I think. Has the message been sent?
No. So what we will do now is we are now in the current time, so it's time to actually fulfill this contract that Dso received. So what we will do now from FLECH is that we activate, if I can find the mouse cursor here somewhere. So what we will do is that we activate the winning bid.
And this is actually more of a reminder, FLECH saying, hey, remember that you actually won this contract.
So I think Karsten should explain what's...
Yes, as you can see at the top, we received a PowerMax activation notification, which translates into the system sending the value to FlexHouse with the PowerMax, and it will run out, as you can see in the debug window at the bottom. It'll last for 30 minutes, and then it will release the FlexHouse again.
So maybe I should just put your attention to the dashboard over here, so you can see that the service has been activated, and right now FlexHouse has actually decreased its consumption to 800 watts. And yeah, actually you will be able to follow along with the temperature, which would decrease during the activation period, because we don't consume as much power as we are supposed to, or what would be ideal for the heating of the house. So for this next 30 minutes, the temperature should decline under normal circumstances, but nothing is normal here, so we'll see.
We're a bit ahead of schedule. This should have been started at 15:45 as it was specified. But then again, that's part of the whole demo thing where we can force things to go. So you don't have to wait here.
We will run for half an hour
Yes. So that means, if you give me back the presentation, that I have half an hour to practice my stand-up comedy. I hope you have a sense of humor, because I don't. No. I'll talk about two things now, actually. First of all, I will go a bit more into detail about what the PowerMax service is, and then I will talk about these three numbers that we see here that I could not convince Anders to force to become something, but I'll explain why in a short while. So first of all, the PowerMax service. This was described in the technical report called FLECH PowerMax Service Requirement Specification. And maybe I should also inject here that a second technical report regarding the FLECH API, so to speak, the protocols, was also made by Olle. This one was made by, well, a bunch of people together. It was Anders, Lars Henrik, David, and Silas, and Henrik. No, you were not part of that one. Me, I was part of that one. So all the nitty-gritty details and thorough explanations are in this technical report that should be published very soon in DTU Orbit. So to explain what the PowerMax is, the purpose of the PowerMax is to maintain the controllable load within a certain area beneath a limit during a certain period of time. So I think we've been seeing this for several times now during the last 2 days. Here's a schematic of what's going on. We can see that at one moment, a transformer will go up in what is usually reserved for a reserve operation. And we want actually to reduce this load. Since we cannot control the green curve, which is the base load, we take the two controllable curves here and press those down, as you can see here. Maybe if I move a bit, as you can see down here. So we will assign a new limit to the controllable load on the grid. I could not resist putting some equations up there. I mean, I know it's late in the day, but I'll explain what's going on here. We're using the usual notation for forecast here, or estimate, which is a hat notation, and the bar notation to design a maximum. So the need of the DSO is the following: that the estimate of the maximum base load, or the peak base load, if you want to call it that, plus the estimate of the peak controllable load should be reduced with some delta power, with some volume, such that the overall load, or the peak load of the system is respected. So that the pieces is what we see down here, right? The question for the DSO how do we define this delta P? How do we actually make a tender, formulate a tender such that this delta P makes sense for us? This is done the following way. The delta P that the DSO formulates for the tender is composed of two elements. Let's start with the second one first. This is the risk associated with the inaccuracies in the forecasts of the controllable load and the base load. You can see here these are forecasts, and then the risk associated to that, plus what it expects the different aggregators will bid in as a volume reduction. Again, we have the hat representing an expectation or a forecast. Which aggregators are we talking about? Well, these aggregators are a subset of all aggregators on the grid that are able to bid in. So that's what this denotes. Again, this is explained very much in this technical report. But I think it makes sense to explain it with equations, even though it's late in the day, because I think it makes it clear. So once the DSO has formulated this delta P, it goes on to formulate the tender. Now, as we saw before, the tender must contain the amount of power reduction from the expected consumption, so that is the delta P DSO that we just defined. A list of point of deliveries. What we saw over here, the point of deliveries, was the point of delivery called syslab and the point of delivery called in0. Then a maximum price to accept. That's something Anas mentioned before. It was, I think, 1,000 crowns in our tender before. This, again, is only for the FLECH in order to do the clearing of the market. If no aggregator bids in below that price, it will say that the market was not successful, and then the DSO can reopen a market. And then the aggregators will see, okay, we bid too high, let's bid again a bit lower. Then the time variables for the service provision, and those are the ones that were discussed before also. Which months and days the service is to be delivered. It could be the case that we see that we have a congestion on the grid every weekday during the months of December and January and February, for example, due to the new resistive heat in houses, for example, or due to new technology or a new factory being built under the radial, something like that. So you're specifying which months and days. As it is right now, we assume every day, but this could be only weekdays, it could be only Wednesdays when you know that there's a specific factory that produces a batch, for example. Then you say between which hours should the service delivery run. So today it was 15:45 to 4:15. And then what Ole mentioned, this green space here, from the start of the service, how long should it take before it's actually performing? So this is more in detail what this PowerMax service is. I don't know if you have any questions. I would like to take some questions now. No? So it's clear what the PowerMax service is. All right. We have some assumptions with regards to how this is set up. And I know maybe some DSOs here or some other people will say, oh, that sounds completely unreasonable. We found out that these were probably the most reasonable assumptions that we could define. First of all, that the DSO is able to separate the total load into a controllable and a base load. So that is what we saw before with the equation, that there's a base load and controllable load, and it's actually able to do forecasts on these two. This means that the DSO needs to have enough grid measurements to do these accurate load forecasts. And with regards to the risk, that the DSO is responsible for the risk of continued congestion whenever it's actually not estimating these base load and controllable load accurately. So maybe it asked for 8 kilowatt, and that's actually what the aggregator delivered, but it didn't help his congestion issue. Well, it's his own fault because he didn't estimate correctly how much he actually needed. So having defined that, I'm going to be a bit shameless, and I'm going to plug in my own research now. I mean, we have 15 minutes, 20 minutes still to run, I think. So if we look right now what's going on here, we can see that it's still performing below the 2 kilowatt. The temperature has not really fallen, so that means that it's actually able to keep it. I should mention that the comfort band here is between 19 and 23. So that is, it's staying more or less in the middle, so that's nice. And now I'm going to explain what these three numbers are. That it's a shame we don't get any numbers here right now, but I'm going to explain why we don't get any numbers. This work was presented at ISGT 2014 in Turkey in the month of October. The paper was called Performance Assessment of Aggregation Control Services for Demand Response. The authors are me and Giuseppe around there, Kai, who's also there, and Henrik, who's also here. So we're all here. what we're looking at is if we have this setup where an aggregator is delivering services to either a DSO or a TSO or BRP, whatever, and at the same time delivering services to a set of DR units, how do we evaluate the performance of this aggregator? The idea behind this is that we could, in theory, by measuring the performance, then during our tests in the laboratory, say, this aggregator performs very well, so this one is actually accepted to perform out in the market, or this aggregator is not very good, so maybe some parts of the algorithm should be reworked and so on. So that's a bit the idea behind this. How do we do this? You can see there's a wrong title there, sorry. What we usually do, I come from control engineering, so what we usually do in control engineering is we make some kind of performance index based upon some kind of performance criteria. There are a load of these ones, and these are only the ones that don't take stochasticity into account. You also have the Harris index and I don't know what, a bunch of other stuff. I decided to stick to the old school stuff and look into integral square error in order to measure the quality and the reliability of the aggregators. So, how do we do this? First of all, we need to model the services. This drawing that you see here is the green drawing that you see over here, actually. This is where the aggregator is allowed to perform. Usually there's a definition of the service where it says it has a band where it can have a certain amount of error. In the PowerMax service, as it's defined by the iPower VP 3.8 technical report, it says it's 5%. And it has 15 minutes to deliver when it's on hour basis. Today it was only 1 minute. We model everything that's in between this red line and the black line as an error that's acceptable, and everything above the red line as an error that's unacceptable. So what we do is we say the quality of service is the error that we have. So that is whatever is above the black line. And we scale it to the constraint, or we scale it to the limit, allowable limit of the service, which in this case is the red line you saw before. In this way, the quality of service is a number between 0 and 1, such that 0 is a good service, means you have no error. 1 is a very bad service because you are approaching the limit. Above 1, you're not performing at all. Then we plug this into a quality metric. This is the integral square error, or the 2 norm. If you're a mathematician, this is the Euclidean norm. If you're a control engineer, the integral square error. Of the asset management service, that is what's being controlled in the house, for example. This could be staying between a bandwidth, a comfort band. And this is the ancillary service, quality of service, that is not going over a certain limit in this case. And then we integrate over time and take the square root of these 2 squares. So this gives you an idea of how the aggregator is performing over a long period of time. What we want to do is we want to normalize this metric by the maximum it could have achieved over time, in such sense that we're normalizing with time, really. In this way, again, we get an eta that has a value between 0 and 1, 1 being very bad, 0 being very good. And the reliability is measured by saying, if I go above, my quality of service goes above 1, then I update a counter that's saying, oh, there was 1 time, 2 times, 3 times that you didn't deliver, you have to pay. This comes from the fact that this is the way how the services are defined nowadays. We could envision a way of defining the services such that as long as their reliability index is below 1, so that we also normalize this with time, then it's an acceptable service. So this is work that's going on, and we hope that the DSOs would see this in the future as an acceptable solution. We performed a case study where we took a centralized model predictive control architecture versus a distributed model predictive control architecture. This solution has been presented in another paper by Giuseppe Costanzo in ISGT 2013. And the idea is that the model predictive controllers are coordinating themselves through a blackboard. I won't go much into detail. If you have questions, you can ask at the end of this part. The base case is that we have 40 households, we have 20 large EVs, we have 10 small EVs, 5 PVs, and then we have some uncertainty in the system reflected in the solar power production. So we can see that we want to keep the load below 150 here. So we're going to cap off all these peaks we have here. And therefore we implement this MPC controller. The results are as following. Having a 10% and a 20% uncertainty on the solar production, you can see we get different numbers down here. It's clear then that the uncertainty affects the performance of the aggregator. Now you may say, well, those numbers are very small, they're so close to zero, I mean, does it matter at all? I mean, this we could round up and then it would be zero anyway. Well, of course, this happens because we are working on a simulated environment, so there won't be communication issues, there won't be any other uncertainty apart from the solar irradiation, so this will look very, very nice, as we can actually see here. I mean, it respects very nicely the power max limit set here. We hope that by doing further tests in the laboratory, these numbers will get closer to 0.3, 0.4, 0.5. Actually, yesterday night, when we were testing this setup, it was going on here. The problem now is that the house reacted faster than I expected. It actually performed very well, and I was telling Anas the whole time, no, it's going to fail. The transceiver is not going to send the right signals, and don't worry, we're going to see some error tomorrow. It's impossible that there's not going to be any error. I have been proven wrong, which is both good and bad. Good for Insero, because then they can say, hey, we have a great aggregator. Bad for me, because then I just have pure zeros there. So at the same time, you can see that we did some simulation tests over several time horizons where we can see that independent of the day, the magnitude of these numbers remains more or less the same. So that is, if we have a very large error in a service that's supposed to deliver only for half an hour, then this magnitude will be, well, it will be a very large number, close to 1, or maybe even above 1. But if you have this large error in the beginning of a service that's supposed to go on for 3 weeks, and it's the only error, then it doesn't matter much in the whole, in the big scheme of things, right? So, why did that one? Okay, this is part of my ongoing PhD work, which is looking into how to define all these service requirements and scenario description and so on in order to do pre-qualification tests on aggregators so that we can certify them. Once they've been syslab tested, we can say, this aggregator is actually able to go out and perform in the industry, perform in the market. We see this as a service we can deliver to aggregators. What I just showed you then was this part down here, which is a verification and evaluation of the aggregators. This part in here, it's a coordinated effort that we've been working on in our lab, integrating the power system, DR units, communication, and the aggregator in such a way that they are plug-in capable, so that we can say we use the actual power system we have in syslab. We have some real DR units, we have some simulated DR units, we have a real ICT platform, or we have a simulated ICT platform, and then we have the aggregator, so that we can work with either pure simulation or with hardware in the loop. So that is the idea behind this part. So, are there any questions with regards to this? I can hear Søren Østergaard commenting something there.
Yeah,
Yeah. Yeah, but there is some heating. This corresponds to, I think it's one or two, it's probably 2 heaters, this one, that's been activated. And we're taking the average of the temperature of the, 7, 8 rooms. So some of the rooms might be a bit colder, some of the rooms might be a bit warmer. We decided that just showing the average was more fruitful. Yeah, so that is why we just hit marginally rising, keeping the temperature.
Maybe I can just comment on that. First of all, there might be a thermal momentum in the system, which will actually take some time before the temperature decreases, because you have some energy in the space heaters, which are made of metal. Second, when we planned this demo, we didn't expect it to be 15 degrees outside. So normally, the consumption will be much higher, but could be that 2 kilowatt is actually enough for Flex House on a day like this. So even though we're only spending 1.8 kilowatt, we are actually still heating the house up. So that could be but yeah, it should be declining slowly, I think. Will.
Yes.
Okay. Will you be in common details with the verification process later on? Because
Actually,
I'm very curious, because now
yeah.
you have asked for 30 minutes, 8 kilowatt down, but 8 kilowatt from what? Maybe he has bought a second machine in the meantime, and he's doing nothing wrong, and he is above your 10 kilowatts or above your 2 kilowatts. How do we want to handle that?
Yes, that is, I don't think we're going to go much more into detail further on, so I'm going back to explain that. That came from, no, I can't find it. Yes, here. The fact that we have some estimate here, and that the FLECH requires a historical data, and the FLECH contains a set of algorithms to predict what would have happened. So it's actually FLECH here who decides, yes, you performed, or no, you didn't perform. And yes. I see you're surprised. The reason is this. When you enter a contract with FLECH, you have an agreement on which method to use in order to do the forecasts. When your bid is acknowledged and been validated and entered into market, it means that FLECH agrees that when you're stating in your bid that you're going down from 10 kilowatt to 2 kilowatt, that is indeed what you would have used. And yes.
The bid is actually a double bid, because you're forcing him to behave like he did exactly 1 year ago and drop down. Okay? Actually, you're limiting the customer in 2 ways. You're telling him you must behave like you did a year ago, and then on top of that, you'll have to drop 8 kilowatts.
Not necessarily that he must behave. It's rather that we're working on estimates here. We're not forcing him to. If he doesn't win this bid, he can perform as whatever he wants. He doesn't need to follow that curve that he would have followed last year, or that he followed last year.
Suppose he wins.
He would probably have something similar, yes, because it's historical data and it's based upon predictions.
Suppose his base load is now, without your regulation, 12 kilowatts. He has done nothing wrong. He has just bought a second machine.
Yes, that is what we say then, that the DSO must be responsible of the risk of failure in the forecast of the controllable load. I can see that Ole has also come to that one.
So I think this is related to this baseline computation. Yeah. And you could imagine that the baseline is computed on a few different days. So taking the day before delivery and the day 1 year ago, and then computing the baseline for the settlement. So we're showing one version of this, and there's still ongoing research about what is a useful algorithm and what data this should be based on.
Okay. Actually, you touched on the point that was a larger discussion while working on these technical reports, and like how would you calculate the baseline, and we kept on running our heads against the wall because of this exact issue. We know that in the US they've gone over to work on schedules. So they say, like 1 week ahead, they say, this is what I will be using. And then you can trust very much on this one because they are bound to that one. Søren, you had a question?
Yeah. Maybe I could just comment on the other question, that the baseline is definitely an open research topic, and we don't have a clear answer how to generate it. But you could also see it the other way around, because luckily it's a pretty warm day today, so it's pretty easy for the aggregator to fulfill this power max. Actually, maybe he doesn't have to do anything, but it could also be the other way around. So who takes this responsibility? That's still open for discussion. So I think Søren Østergaard will.
Yeah, okay, so the Energy Flex house have to the services it delivers is max 2 kilowatt hour, but the DSO needs 8 kilowatt hour.
No.
Decrease.
The DSO needs to decrease 8.
Yeah.
So that means that the Flex house expected to use 10.
Yeah.
And what they've done is they've bid in these 8 to go down to 2, a maximum of 2.
Yeah, but then now the DSO have a problem, because I saw that just before switching it off, it was 3.4. So it's only 2 of the 8 kilowatt hour the DSO actually
Yes, but
gets.
we're also saying it's the peak value. It's the peak value that we look in. If we had continued for 15 minutes more, it might have been up at the 10.
Yes, but if the DSO actually needs the 8 kilowatt, then the DSO have to get 6 from elsewhere, because Flex house is only delivering 2.
But it's the same problem. It's the same baseline problem, because it was only delivering.
But this is only the baseline for the Flex house. But the rest of the grid still needs 6 more.
We don't know that.
No, but they anticipated that.
Yeah.
If I can just pick up this question, I mean, we forecasted that Flex house would consume 10, and that's what the DSO based its estimate on. And compared to that, we did downregulate 8 kilowatt. But the observant one, maybe that was what you said before, we were actually consuming 3.5. So actually, Esteban did prove me wrong, that it wouldn't be perfect. And we have had some problems with actuators in Flex house. And I think we will see that in the settlement phase, that we didn't fully deliver. We actually did consume 3.4, I think, kilowatt in an instant of time.
I think Anna has a question in the back. Or maybe a comment.
Hi. Let's assume that this aggregator would work every Wednesday in the evening when people are coming back from home. And then this data would be put back to FLECH, and then FLECH would assume that every Wednesday we would have a data that this house doesn't consume anything. So after some time, in a few months, it would notice that, oh, actually I don't have this problem anymore according to my prediction, because the house was not consuming on that day, and then it will not order this service again. So how would you
that is
solve
exactly what happened in the US, and that's why they went on to work on these operational schedules, because once you start messing around over a long period of time with the flexible demand, then you cannot predict really anymore, because you don't have historical data. I mean, an option would be also, instead of using data from a year before, base your forecast only on the meteorological data, for example, where you say, we can see that a storm is coming or that the temperature is going down, so we know that, generally speaking, when the temperature goes this much down, the load will increase this much. And then operate maybe not on very specific forecasts, but on rules of thumb, saying, when we have this temperature, we should probably ask for this much service. I think that goes a bit more with how the DSOs operate today, using these rule of thumbs. Actually, the house has been released now, because we were in the... we've had half an hour to burn off now, and you didn't even need to hear me tell jokes. That was nice.
I think Lars Henrik has a question, or maybe a comment?
More a comment. What you touch upon is the fact that we are using these DER units, which are more or less stochastic. So when we start to operate them, is their behavior due to control, or just because they are out there and now they want to be utilized? So the issue you touch upon here is not only a FLECH problem. You would have the same if you go to the ancillary service delivery, that if you provide something for the TSO, you need to prove afterwards, if the TSO requires it, that you have delivered the service, kind of. And you touch upon a problem here that is difficult to show whether the behavior was that due to active control or just a stochastic phenomenon.
All right. I think one last question, and then we go on to the settlement.
Very much the same, along the same line. How do they in the US prevent the aggregator from behaving malicious, you know, creating artificial overloads?
That is an answer I don't know. I mean, my guess is that you have to work on regulation in that aspect.
Maybe we can pass the microphone on to someone
Yeah,
really
to
working with
notes,
markets. So,
Yeah.
Silas?
Yeah, well, in the US it has actually caused quite huge problems, and also lawsuits on manipulative behavior on baseline, because they base it on like 3 max load days out of 5, and then you can actually go in and pick the days that you would like to be in and out, and choose a high days and get a high baseline, and etc. So it has actually caused huge problems, and that's also why it's still an area of heavy research actually that goes into this. And as we understand, they start to work on those like operational schedules for at least for the larger consumers to deal with that issue. And there, of course, you take some risk on whether you estimate the actual load right, but you avoid the manipulative behavior from the aggregators. But obviously, there's not a very clear and answer to it yet. Yeah.
I think we will go on to the settlement in order to not keep you here longer than you need to. So that means that the FLECH operator, and well, for some reason it's not Ole pushing the button, but it's actually Anders doing it. He will say settle, and yeah, I need to go forward here.
As you can see on the dashboard, we have exited the activation period, so now FlexHouse is actually allowed to consume whatever it wants, and now we increase the consumption again to 8 kilowatts, trying to get back to the 21 degrees, which we had before. So that's why the consumption increased quite rapidly. So now we can let the FLECH do the settlement. Let me just push the right button. So I think maybe Ole can speak a bit about, I will try to extend the plot here. So
what you see is that right now everything happened very quickly, and you see that we got the meter data from the DSO showing that Dso actually almost delivered all the time, except for one minute there. And even though they didn't deliver, FLECH accepted this as full delivery, and an invoice was sent to the DSO and payments to Dso. So, do you have anything to?
Yeah, I just want to add that these payments, they're not real payments, because if we had to pay for every time we ran a test in the last few weeks, Dso would be poor now. I think that is what there is to say about the verification that or the settlement that we haven't touched upon before. Again, it's all this issue, is it actually respecting or doing what it would have, going down from the 10 peak and so on. It's an open question, but we've done the settlement this way.
Yeah, maybe we can just have a quick look back at the aggregator window and the DSO window. So if we take the DSO first. So here, we actually did get a request here. So that the market with this market ID that we created earlier this morning has been finalized, and the aggregator actually delivered. So we get a notification for paying the $400 or euros or whatever amount of money to Dso for the service they delivered. And I think, hopefully, likewise, we can see in Dso's window. Yeah, maybe Carsten, you can present that you did receive. Or maybe you did not.
You didn't receive? We can see here that they released the Flex house once again when the service was finished.
Okay. Well, Dso should have received a payment message stating that they have to get $400, euros or whatever, from the Syslab DSO for finalizing the service. No.
Yeah. Well, they don't want the money enough, so. No, because the messages appear in the top, the new messages. So it should have appeared in the top. Anyway, let's go back to the presentation. What can we say about what we just saw? We saw two things, roughly speaking. That the maximum peak of the controllable load, in this case, was reduced to 2 kilowatt, almost. We had a hiccup there. And this would, in turn, have alleviated the congestion issue. Looking back, what we've shown is we went through a planning phase where we stated the problem of the DSO and how they would acquire a service, they formulate the tender, send it to FLECH, get bids back from aggregators, doing the clearing, so on and so forth. We've been through the operation phase, which is where I burned off half an hour here talking to you. And finally here, the last part of the settlement. Now this shows three main points about FLECH. One is that we've managed to work on the standard communication, which is described in the technical report done by Ole. So that was one of the first points, or one of the main points that we wanted to, why we wanted FLECH, is we want to standardize communication between Aggregator and DSO. The second point is it was transparent. We could see out here in the FLECH clearly who was bidding, so on and so forth. So there is no risk of anybody cheating and getting ahead of the queue. And we have the visibility for potential suppliers. Whoever is registered with a FLECH, they will get the notification if there is an open market within their area. The last point, the fourth point, which was about the legal terms, I don't put that one here because we didn't talk that much about it in the presentation itself. I think it came on with the questions. I mean, it's clear also that FLECH, being a market operator, serves as an economic and legal liaison between the DSO and the aggregators. So, any more questions? Yes, Giuseppe?
Thank you. We see now that the Flex house is released from the service and is consuming 7.7 kilowatts, clearly showing that the external conditions require some consumption in order to deliver service for the users, let's say, which is in terms of temperature. How this, if this is fed back to the aggregator, does the aggregator know how the user is feeling because of this power max? And if not, do you think it would be possible to insert this in FLECH and extend this framework?
Well, that's not part of FLECH. FLECH doesn't care about the user. That's why there's an aggregator there. The aggregator is the one that's responsible of taking everything that's related to the end customer, to the user, putting a screen in front of that, and then just showing the service towards the DSO. And that's why FLECH is there. With regards to the feedback to the aggregator, well, you would have to ask the people from Dso if they actually receive feedback from the users. In the case of the Syslab aggregator that we have, yes, we would be able to measure what's going on. And I expect that most aggregators will do some kind of closed loop control in that sense. Again, take the question up with the people from Dso. Kai has a question?
Well, let me allow to start up with a follow-up comment. The there is actually the customer performance indication on the presentation as well. You didn't have a chance to get into this because it hasn't been part of the service specification you presented. But there's in terms of evaluation or validation of the aggregator, you need to look at both ends, what the customer experience is and what the service for the DSO experience is. And FLECH is not responsible for what the customers experience. So I would like to turn that into a question, basically, to Encero. Would you care to have such indexes that allow you to have a sort of dashboard experience of the customer? Or do you think you would use other means of evaluating customer performance sort of on the fly? So I would like to turn that into a discussion here.
We have Thomas here. I don't know if I'm being mean by
Thomas will try
pointing at him.
to answer that question.
Well, here we are dealing with a house and some temperatures. Before we were dealing with some vehicles and some electrical batteries. I think it's going to be very difficult to have a dashboard for all customers in a village like Stenderup, for instance, where we should monitor if they feel good about what we are doing online and track that every day. I don't think that it's going to be the case. I think we will. We could aggregate it. Yeah. We could use of course, you could use the temperature out there to some extent, but the question is if it will be used, and I doubt that actually. If we had, say, 20 houses or 30 houses or 100 houses, would we use that for monitoring the comfort of many office buildings or many houses on the fly? I doubt it will be used. I doubt.
Yes.
But when do you send the money?
So wait for the phone call when they're having a cold shower. Okay.
In that case, you will be waiting for the call. Yeah.
The aggregators. If you have, let's say, a pool of customers, say 100 or 200, and you place a bid on the FLECH market, so how would you divide the power max, let's say, to each customer in order to achieve that bid? How would you divide this service among the customers? Because the customers have different needs, and probably some families are not even at home, so you can actually reduce much more in some houses and less in others, and generate and have a general customer experience that is good, actually. So that would be, it's my first guess, if you would be possible if you have some sort of feedback from customers and use that in order to optimize the signal you send them in order to control the systems at lower level.
Do you want to answer to that one? Thomas, it's down here.
Well, it's a matter of implementation, just to answer with your own phrase.
What we have decided to do is to give the end user some comfort bands that they can use. Say, I want the temperature to be between these two levels. And as such, we don't care if they are home or if they are not at home. And we don't monitor that at all. And there could be several reasons for that. Us monitoring that might not be wanted by the end user at all. You can actually see a lot from the house power's consumption already, and knowing if they're home might not be interesting for them. So I think you should turn it around and say, give the user some comfort settings, and let the user be able to control these settings on a daily basis or whatever, and then make sure that you steer between these comfort settings as an aggregator. And if you're outside the band or outside the limit, you'll be absolutely sure that the customer will call you or the end user will call you and say, hey, there's something wrong here. Or maybe they will not call, but adjust their settings so that their flexibility is set to zero essentially. So that's what I think we will see instead. We will not wait for them or communicate with them on a daily basis or whatever to hear if they are okay. So it will be something with a comfort setting that they can use, and that way can communicate with the aggregator.
Okay. I have a question then for the DSO, if I may. We have been showing, I showed during the presentation, this concept of stamping an aggregator with a performance and saying this is validate or this is an aggregator that is able to perform in the market. Would it help the DSO or the DSO's worries if they knew that there was such a scheme that the aggregators participating in the market were certified before actually entering the market? You were think a fine. Okay, so if they don't perform, they pay money.
Exactly.
Yeah. So you wouldn't be interested in having this kind of stamp for you. No.
It's a legal agreement, and
Yeah.
Trust is good, but control is better.
Okay.
And punishment even better.
Yeah. All right.
This is something we have discussed a lot with the VP5. And my immediate response would be the same as you just gave. But I think we have discussed it a lot, and I think we do not want to go down this track because we will scare off the aggregators. Nobody wants to take this big risk if they know there's a big fine out at the end. And of course, they should not enter a contract unless they know that they could provide. So I think that could be an answer to you. Now that we have DSOs in the room, could I take the chance here to ask actually two questions? Do you think that, do you have challenges in your grid that could be solved by a smart grid method? And could you see yourself solving this problem with a marketplace as a FLECH?
Well, I'm not the CEO, so I'm just an engineer. But I think the example with the transformer is a very bad one. I think you were thinking of a 10 kV transformer,
Yes.
and we just take off the lid, and for no money take a spare transformer, and the input is one side larger, no problem, no money, nothing, no problem. So maybe if it's a feeder and it's in winter time, that's actually for a very short period, maybe for a year or something like that, when we can't get in the ground. And of course, if you have it on a lot of problems, a lot of flexibility, the problem will move to higher levels, and then we can't just exchange the transformers. Then there might be a problem, but that's in a very long time. Maybe, yeah.
Not coming from a DSO, but working for a lot of them. Well, I think it's very important to see smart grid solution as a part of the solution. Sometimes you have to reinforce the grid, and smart grid solution will be used if they're economic feasible. So you should really see if as Morten mentioned, if to change a transformer, well, there you can use the small ones you exchange at another place in the grid. But if you have 1 kilometer of underground cable, well, you don't take it up and dig it down again. So in some areas, well, smart grid solutions are economic feasible. In others, well, changing equipment. You should look at the age of equipment. If you have some equipment creating a bottleneck, but at the end of the lifetime, well, you have to exchange it in the coming years. So it's a part of the solution. In some areas you will see grid reinforcements, and that's not a bad thing. That's also a part of the solution. But it should always be economic competitive to traditional grid reinforcements.
Yeah, one more thing, if I may. Today we are reinforcing the grid due to embedded generation. So it's actually shedding embedded generation that's interesting. It's not, maybe of course you could increase load, but I think that's a troublesome one. So it's more shedding embedded generation, I think.
Are there any other questions? If not, I will pass on the microphone to Henrik, and I think he will close off. Which one do you want to use? Yeah.